This lesson we're going to talk about gravity and friction. If you take a look at the picture here, this lady looks like she's having an extremely bad hair day. However, take a closer look and it looks like she's floating. This is an astronaut in training, and she happens to be on an aircraft that flies at steep angles and provides a sense of weightlessness. Why doesn't she fall? That's my question to you. Why do you think she doesn't fall? Okay, well, here's the airplane right here going up, and then here's the airplane coming down. Notice the angle and how steep it is. The reason why she doesn't fall is that she does fall. Earth's gravity pulls the astronaut down, but the aircraft moves downward at that same speed, which makes her appear to be floating weightless. Okay, so in this lesson, as in the past lessons, we have some things that you need to write in your science journal. The first ones I want you to write would be the key concept questions, or essential questions. That would be these 3 bullet-pointed questions right here. The first one, what are some contact forces and some non-contact forces? The next one, which is this one here, what is the law of universal gravitation? And the last one is this here, how does friction affect the motion of 2 objects sliding past each other? Okay, I want those 3 questions written down in your science journal, and you can answer those when you come across the information in this recording. Okay, all 3 of those questions. So remember that you can pause this and write your questions down. If you don't understand something, you can run it back and play it again so that you do understand it. Okay, so those are the 3 essential questions that I want you to answer within this lesson. Okay, so the next thing, of course, is our wonderful vocab. All right, I need you to write the vocab words down. When we come across them in the recording, I want you to write its definition. Okay, so the first one would be force. The second is contact force. The next one is non-contact force. We have gravity. We have mass. We have weight. And we have friction. Those are the things, vocabulary words that I want you to write down. Write their definition when we come across them. Okay. So now, I have some questions in reference to some of this information right here. Okay, so I'm going to go ahead and make this a little bit larger. Okay, this also goes in your science journal, please. And this one you should be able to answer right away. How does gravity affect the motion of an object on Earth? Okay, so you have that one. Let's get the next one up here, please. Okay. What are some problems an astronaut might experience while traveling in space? Remember, you're writing these in your science journal and answering them to the best of your knowledge. And then the last question I have for you for right now would be, what change could cause an astronaut to appear to fall relative to the aircraft? Relative to the aircraft. Okay, so write all 3 of those questions down. Answer them to the best of your knowledge, and we will go over them in class. Remember that you can pause this and write the information down and answer the questions and start it again once you're done writing. Okay, so right now I want you to think about all the things that you may have pushed or pulled today. You might have pushed toothpaste out of a tube, or maybe even pulled a chair out to sit down. A push or a pull on an object is called force. So force is one of our vocabulary words, so please write down your definition and your vocab word, please. Okay. A push or a pull on an object is called a force. All right, so bringing that back down, that goes in your science journal. An object or a person can apply a force to another object or a person. Some forces are applied only when objects touch. Other forces are applied even when objects do not touch. So now we're going to talk about one of those forces, and it's called contact force. If you take a look at the picture right here, you will notice that the hand of the karate expert applied a force to the stack of boards and broke them. You've probably also seen a musician strike the keys of a piano and an athlete hit a ball with a bat. In each case, a person or an object applied a force to an object that it touched. So I'm giving you a definition now. Okay, I'm moving this up and rolling it out. Okay, the next definition is a contact force. Contact force is a push or a pull on an object by another that is touching it. Okay, so in this case, there was a contact force on the boards by the hand of the karate expert. Contact force can be weak, like when you press the keys on a computer keyboard. And they can also be strong, such as when a large section of underground rock suddenly moves, resulting in an earthquake. The large sections of Earth's crust, called plates, also apply strong contact forces against each other. Over long periods of time, these forces can create mountain ranges, and that happens if one plate pushes against another plate and pushes it upward. Okay, so now we're going to talk about non-contact force. What I want you to do is, I want you to lift your pencil up, and then I want you to release it. What happens? The pencil falls to the floor or to the desk. A parachutist falls towards Earth even though nothing is touching him. A force that one object can apply to another object without touching it is called a non-contact force. That would be our vocab word. So please write the definition down in your science journal. A force that one object can apply to another object without touching it is a non-contact force. Okay? All right. Gravity, which pulled on your pencil and the parachutist, is a non-contact force. The magnetic force, which attracts certain metals to magnets, is also a non-contact force. What I want you to look at is this picture right here. Another person with a bad hair day. You might think that I'm doing this on purpose. But what a great picture, because when you look at it, this is another non-contact force called electric force, which is causing the girl's hair to stand on end. Notice that she's not really touching the hair. All she's touching is the balloons. The balloons actually are pulling on the hair, which is a non-contact force. Okay, so now what I want to do is I want to introduce you to some questions, and I want you to try to answer these, please. Okay? First one. When is gravity a non-contact force? And I want you to give an example, please. All right, the second one. Why does hitting a ball with a racket involve a contact force? The next one. Notice the yellow key or the gold key with the red check mark. That makes that one of our main key concepts. Okay, so one of our main questions we have to answer. What are some contact forces and some non-contact forces? I want you to list two of each, please. 2 contact forces and 2 non-contact forces. Okay, and then the last one, I'll make this a bit smaller. The last one is an example one. Okay, so what I want you to do is read this question, which says, air resistance is a force that opposes the motion of an object as it moves through the air. Is air resistance a contact force or a non-contact force? Okay, so just answer with either contact force or non-contact force. Okay, think about the question. All right, so I'm going to make these smaller, whoops, and put them back. Because believe it or not, now I want to talk about strength and direction of force. Strength and direction of force. Okay, so maybe you knew this or maybe you didn't, but forces have both strength and direction. Let's think about this. If you push a textbook away from you, it probably slides across the desk. What happens if you push down on your book? It probably doesn't move. You can use the same strength of force in both cases. Different things happen because the direction of the applied force is different. Okay, so you are applying force to the textbook to slide it across the table, or you are applying force straight down on the textbook, which caused it not to move at all. Okay, so now I want you to take a look at a visual aid. Hold on just a second. Bring it over here. Okay. If you take a look at this photo, you'll notice red arrows pointing in a certain direction. Arrows can indicate the strength and direction of a force. The length of an arrow shows the strength of the force. Notice in this figure here that the force applied by the tennis racket is stronger. Okay, the force applied by the tennis racket is stronger than by the table tennis paddle, right here. As a result, the arrow showing the force of the tennis racket is longer. The direction that an arrow points shows the direction in which the force was applied. Okay, so we notice the arrows are going away from both rackets, which means the force is being applied in that direction. Okay. The SI unit of force is newtons, or N. If you take a look in the diagram right here, you see 100 N, or 300 N. Okay, so that would be 300 newtons, or 100 newtons. Okay, so just to give you an indication, you apply a force of about 1 newton when lifting a stick of butter. And you use a force of about 20 newtons when lifting a 2-liter bottle of water. Okay, so if you use arrows to show these forces, the water's arrow, the water bottle arrow, would be about 20 times longer. Okay, so in this case, then, when we take a look at these two arrows, this one should be about 3 times longer than this one. 3 times longer. I do need you to remember or to understand that motion of an object is affected by the strength and direction of the force that's being applied to it. Okay? So in this case, I want to go ahead and give you 3 more questions. All right? So write these in your science journal and answer them, please. What is an applied force? That would be 1. All right. The next one. How are the length of the arrows related to the different forces on the 2 balls? And that's this one here referring to this picture and this picture. Okay. How are the lengths of the arrows related to the different forces on the 2 balls? The last one I want you to look at, and I'll move these up a little bit, give us some room. What are some ways a person can apply a force to an object and not affect the direction of motion of that object? We talked about this one a few minutes ago. Okay, so write all 3 of those questions down and answer them, please. All right. Okay, now I want to talk about gravity. When you think about gravity, you think about objects falling. Okay, so when objects fall to the ground, it's because Earth exerts an attractive force on them. Did you know that you also exert an attractive force on objects? Okay, so what I want to do is I want to give you our definitions. Hold on just a second. Okay. You'll notice that there are two there. One is gravity, which is an attractive force that exists between all objects that have mass. And the other one is mass, and mass is the amount of matter in an object. Please write both of those definitions down so that you have them to study from. I want to clear up a common misconception, and that is that gravity is a force that one object exerts on another. That's not correct. What I need you to know is that gravity is a force of attraction between two objects, each that has mass. Okay, so now I want to talk a little bit about the law of universal gravitation. In the late 1600s, an English scientist and mathematician, Sir Isaac Newton, developed the law of universal gravitation. This law states that all objects are attracted to each other by a gravitational force. The strength of the force depends on the mass of each object and the distance between them. Gravitational force and mass is one of the things we're going to talk about. And so to start that off, I'm going to say the way in which the mass of an object affects gravity is shown in this diagram right here. Okay? When the mass of one or both objects increases, the gravitational force between them also increases. Okay, so I want you to take a look. You'll notice that these two objects are the same. Same size. If you notice the arrows, both arrows are the same length. But in the second part of this diagram, what you're going to notice is that this has stayed the same, but notice that the arrows have changed. Do you know why? What's different about the two objects? This has gotten larger. The mass has increased. So because the mass of this object has increased, the force between the two has also increased. Okay, let's move down to this one. Now you'll notice that this object has increased to the same size as this object. Notice the lines. The lines have also gotten longer, which shows an increase of gravitational force. Okay? So I wanted you to see that because that does make a difference. Gravitational force increases if the mass of at least one of the object increases. Okay, so now let's talk about gravitational force and distance. The last one was force and mass. This one's force and distance. The effect that distance has on gravity is also shown in this diagram over here. Okay? The attraction between objects decreases as the distance between the objects increase. Okay, so we're going to use you as an example here. Okay? If your mass is 45 kilograms, the gravitational force between you and Earth is about 440 newtons. On the moon, however, which is about 384,000 kilometers away, the gravitational force between you and Earth would only be about 0.12 newtons. So to sum up that example, because the distance between you and the gravitational force of Earth has increased, all right, that means that the force that is being applied is less. Okay, so let's take a look at this diagram here. Okay, you'll notice that all of the objects that are here are the same size. Okay, so we're not talking about mass, we're talking about the same size, and this one deals with distance. If you take a look at this first diagram, you'll notice that the two objects are fairly close together, and the force between the two of them is this distance. But as we move the objects farther apart, what happens to the arrows? They get smaller because the force between those two objects is decreasing. As we move it further apart, again, smaller arrows. So what I need you to remember is this, The gravitational force between objects decreases as the objects move apart. Okay, so now I want you to answer 3 questions for me. You're writing these in your science journal and answering them. Okay, that would be this one here. What factors determine the amount of gravitational force between 2 objects? The next one, you'll notice the gold key with the red check mark. What is the law of universal gravitation? That is one of our key concept questions that we are needing to know to show success in this lesson. And the last one, how do you know that gravity exists in outer space? Okay, so I want you to write those 3 questions down and make sure that you're answering them to the best of your ability from the information that we've just talked about. And also maybe think about a reading check question from the information also, which says, what effect does distance have on gravity? What effect does distance have on gravity? Okay, we'll be talking about that one in class. Okay, now we want to talk about weight, which is a gravitational force. Earth has more mass than any object near you. As a result, the gravitational force Earth exerts on you is greater than that force exerted by any other object. So now we come to the next vocabulary word, which is weight. Weight is the gravitational force exerted on an object. Please write that in your science journal. Okay, so that you have it to study from. Near Earth's surface, an object's weight is the gravitational force exerted on the object by Earth. Because weight is a force, it is measured in newtons. Okay, now let's talk a little bit about the relationship between weight and mass. An object's weight is proportional to its mass. As an example, if one object has twice the mass of another object, it also has twice the weight. Near Earth's surface, the weight of an object in newtons is about 10 times its mass in kilograms. Okay, so you might think that astronauts in orbit around Earth are weightless. However, their weight is about 90% of what it is on Earth. The mass of this astronaut here, you'll see these little things here. I'll make this a bit larger. Okay. You'll notice that the mass of that astronaut is about 55 kilograms. Her weight is about 540 newtons on Earth and about 500 newtons on the space station. Okay, so to give you some information, the space station is about 350 kilometers above Earth's surface. So you may ask, why is there no significant change in weight when the distance increases so much? It's because Earth is so large that an astronaut must be much farther away for the gravitational force to change much. The distance between the astronaut and Earth is small compared to the size of Earth. Something else I want you to notice between these 2 pictures and the information that's here is the mass. Notice that mass has not changed. Okay? However, depending on where this astronaut is, the weight has changed. Okay? So the distance between the objects has increased, which means the force pulling the object in has decreased, just like in the diagram before. Okay, so now what I want you to do is, we've got our all-important questions that I want you to write in your science journal and answer. Why does the weight of the astronaut change when she travels from Earth to space station? Okay, that's question 1. Remember, you're writing these down and you're answering them. The next one. What is the relationship between mass and weight? What's the relationship between mass and weight? The next one. Why is the gravitational force that a friend exerts on you less than the gravitational force exerted on you by Earth? Okay, so your next question is one you're going to have to use the diagram of the astronaut to answer. This diagram that was over here, okay? What would be the weight of a 110 kilogram object on Earth, and then that same object on the space station? Again, you're going to need to use this information. These two boxes will help you. Okay, take a look and see what you can do with that. Okay, your last question is, explain how the sun's mass affects the solar system. Okay, those questions need to be written in your science journal, and they also need to be answered, please. Okay, so now we're going to talk about friction. If you slide across a smooth floor in your socks, you move quickly at first and then you stop. The force that slows you is friction. Okay, friction is one of our vocab words, so please write this definition down. Friction is a force that resists the motion of two surfaces that are touching. There are several types of friction, which we're going to get to in a few minutes, but please make sure that you have this vocabulary word as well as that definition written down. Okay, so now we're going to look at this diagram right here. Slide that there, slide this over so you can see it. The box on the left-hand side, right here, does not move because the girl's applied force is balanced by static friction. Static friction prevents surfaces from sliding past each other. Up to a limit, the strength of the static friction changes to match the applied force. If the girl increases the applied force, the box still will not move because the static friction also increases. So what I want you to take a look at is these numbers right here. Here's your applied force. If you take a look, the static friction is applying the same amount of newtons in the opposite direction that the girl is applying the force, which means the net force change is 0. Okay? So next, sliding friction. When static friction reaches its limit, where it can't hang on any longer between the surface and an object, the box will move. Okay, so looking at this part of the diagram, the force of the two students pushing is greater than the static friction between the box and the floor. Sliding friction opposes the motion of surfaces sliding past each other. As long as the box is sliding, the sliding friction does not change. Increasing the applied force makes the box slide faster. If the students stop pushing, the box will slow and stop because of sliding friction. So let's take a look at the numbers. The applied force is 200 newtons. The sliding friction is 70 newtons in the opposite direction. So the net force change is 130 newtons. So what you're doing is you're taking 200 minus 70 and giving you the answer of net force of 130 newtons. Okay, so when we're taking a look at this picture here, why are the arrows for the friction force and the applied force in opposite directions? It's a question you need to think about. If you notice the arrows, they're in opposite directions. The students are pushing this direction. The sliding friction is pushing this direction. But notice the size of the arrows, as we talked before. There is more force being applied here than is being applied here. How does the equation show you that the object on the right is moving? How does it show you that this object is moving? Well, let's take a look at this equation. Applied force, the arrow is longer, 200 newtons, okay? Just as we talked about before, sliding friction is minus 70 newtons. The minus means it's going in the opposite direction from the applied force. which means your net force is 130 newtons, which shows that the object is moving. Okay, so I want to make this understood and to remind you that friction is a force, and like all forces, it affects the motion of objects. I also want to remind you that friction is a contact force. Remember, contact force to objects that are in direct physical contact. I want you to understand that in order to move an object, you first have to overcome that static friction between the object and the surface with which the object is in contact. To keep the object moving, you have to apply enough force to overcome sliding friction. The object stops moving when the applied force is less than or equal to the sliding friction. What I want you to be thinking about is the type of surfaces that produce more sliding friction and those that produce less sliding friction, and we will talk about those in class. Okay, so now I want to talk about something called fluid friction. Fluid friction. Okay? And just so you know, a fluid, in this case, is any material such as water or air that flows. Friction between a surface and fluid is fluid friction. Fluid friction between a surface and the air is air resistance. Suppose an object is moving through a fluid. Decreasing the surface area between the oncoming fluid decreases the air resistance against the object. So in this case, we're looking at the flat piece of paper versus the paper wad. The crumpled paper falls faster than the flat paper because it has less surface area and less air resistance. Fluid friction, like other forms of friction, oppose the motion of surfaces that are in contact with it. In the case of fluid friction, the interaction is between a surface and either a liquid or a gas. Okay, so now I want to ask some key questions for you to answer. Okay, I'll be moving these up here. All right, those questions are right here. Question number 1 right here. What are some examples of fluids you have encountered today? Just some fluids that you have encountered today. The next question I want you to write down. Why does decreasing the surface area of a piece of paper decrease its air resistance when it is dropped in the air? The next one is this one here. What are some other factors besides surface area that affect the amount of resistance on an object? Answer those questions. Make sure you're writing those questions first and then answering them from the information we just talked about. Okay, so let's talk about causes of friction. I want you to rub your hands together. What do you feel? If your hands were soapy, you could slide them past each other easily. You feel more friction when you're rubbing your dry hands together than you would rubbing your soapy hands together. Okay, so I want you to take a look at these two pictures. This one here and this one here. Okay, so the question is, what causes friction between surfaces? When you take a look at those two photos, this one here and this one here, you might notice that one individual is going to be able to slide better than the other two. This one here specifically can slide better than this one, even though I'm quite sure they're trying to slide. When surfaces slide past each other, they have little dips and bumps. And dips and bumps cover all surfaces, no matter which surface it is. When they slide past each other, the dips and bumps on one surface catches on the dips and bumps of the other surface. The microscopic roughness slows sliding and is a source of friction. As you may already know, in addition, small particles such as atoms and molecules make up all surfaces. These particles contain weak electrical charges. kind of like the hair with the balloon that we saw earlier. When a positive charge on one surface slides by a negative charge on the other surface, an attraction occurs between the particles. This attraction slows sliding and is another source of friction between the surfaces. Okay, so when we take a look at these two pictures, from the information we learned about dips and bumps on all surfaces, this individual has probably a better chance of movement and less friction because of the surface itself. The less dips and bumps, more dips and bumps, if you notice. Okay, so this will have more movement than this one will. Matter of fact, this one will probably have static friction, no movement at all. Okay, so let's make these smaller. Okay, and ask you the all-important questions for this lesson one anyway. Okay, notice that you'll have the gold key with the red check mark, which means it is a key concept question that is important for your success. How does friction affect the motion of two objects sliding past each other? Okay. And the next one is, what are two causes of friction? What are two causes of friction? That's this question and this question. Please write them and answer the questions, please, in your science journal. Okay, so now what we're going to talk about is reducing friction. Okay, remember rubbing your hands together, and when they're dry, they create more friction, which is kind of heat that heats up. And the soapy hands that you had when you rubbed them together slid past each other a lot easier. We also need to remember that friction is caused by bumps and dips on surfaces, and that includes your hands. So when you rub soapy hands together, the soapy water slightly separates the surfaces of your hands. There is less contact between the microscopic dips and bumps and between the electrical charges of your hands. Soap acts as a lubricant and decreases friction. With less friction, it is easier for surfaces to slide past each other. Motor oil is a lubricant that reduces friction between moving parts of the car's engine. Okay, so what I want to do is, I want to go back to this picture right here with the air resistance. And I want to look at it again, okay? Reducing the paper's surface area reduced the fluid friction between it and the air. So by taking this piece of paper, which has more surface area because it's in one big piece, and wadding it up and making it like this, you have reduced the friction because you've reduced the surface area. Okay, so the next thing I want to do, okay, I'm going to make these smaller and make this larger because last two questions I want to ask you, have you write them in your science journal and answer the question is, how do lubricants reduce friction? How do lubricants reduce friction? And the other question is this one here. Which type of fluid would you expect to reduce friction more? A dense fluid or a less dense fluid? And I want you to explain, please. Make sure you're doing the explaining. Okay? You should be able to answer both of those questions using the information from this lesson. I just want to make sure that you understand that lubricants are used to separate surfaces in contact with each other, thereby reducing friction. Okay, thereby reducing the amount of friction in those objects. Okay, last thing I need you to do is the lesson review. You do not have to write the questions, however, you do have to write your answers. You're doing this in your science journal. Okay, the one thing I do want you to include, though, is this. This right here needs to be written in your science journal. So I want you to make the graph. I want you to draw the chart, please. Okay, and then I want you to answer all the questions. I hope you've learned a lot of information, or that we've recovered some information that you already knew and that you hadn't covered in a while. I know you're going to do well on this lesson review, and I also know you're going to do well on the quiz.